Well, welcome to the additional October SMP video conference. We're going to be talking about the strategy for evolving whole systems modeling capability, which was presented by Jack Ring a couple weeks ago, first of the month. So if there's any questions or thing you'd like to talk about, have Jack talk about a little more in detail, or if you have any questions or so forth, feel free to speak up and get the party started. Over to you, Jack.
Okay, thank you, Joe. I contributed this material not for the purpose of discussing whole system modeling, but simply to show how we used some of Warfield's interpretive structural modeling procedures. We think we used them pretty accurately, according to John's intent. but the purpose then is to simply show an example of how ISM was used and the kind of clarity that it can bring to a very complex and situation in which the participants don't necessarily, in fact, typically do not have a common notion of the situation or even a common intent on what should be done about it. This example is one of 5 such sessions that we have held with various. Well, the first one was with the master's program at ASU that is run by Ben Broom, who, as a college student, was a student of John Warfield's, and as his doctoral program, his doctoral work, he went to Cyprus and conducted interactive management sessions with the 2 opponents in Cyprus for the better part of a year, and they became cooperative agents for the benefit of Cyprus, no longer arguing between who's Greek and who's Turkish. So that was one session that we experienced, and then we have run 4 such sessions for corporations who have realized that they need to get their act together, that times are changing, and the way that they have been successful in the past isn't going to work anymore. So I suggest, unless you have questions about the basic idea of whole system modeling, that we simply look at the the interpretive structural modeling part of it.
That would be somewhere in the charts here, Jack.
Pardon?
Yes. So
could you say, Jack, a bit more about what other approaches have been tried before you did ISM and how they might have compared in trying to get to a strategy of whole system modeling?
Well, yes, the motivation for applying Warfield's work is because, as you well know, 50% of system engineering projects fail to satisfy their stakeholders. And our view of the reason for that was this presumption up front called requirements and requirements engineering, which years ago Ivar Jakobsen and his use case crap got people off on the wrong track. And we've been off on the wrong track for the last 35 or so, well, since about 1985. Around that time, system problems got to be so large and complex that when one started with a list of system shell statements written in elegant English, they proceeded to create a system that had no purpose. And we perceived that first you have to understand the problem that the system is supposed to address before you try and understand what the system shall do to address that problem. So the conclusion was that we must create a descriptive model of the problem system first, then a strategy for intervening with what the stakeholders don't like about the problem system, and then that strategy formulates the set of challenges that the system you're going to build must deal with. So in order to then understand the problem system, you need to go look at the problem situation and discern out of that what's going on in that mess and what's the underlying actual system of interactions that's occurring in the situation, problematic situation, that the stakeholders want to suppress.
That's a real good point, Jack. I think there's some barriers to that are built into the human psychic and the human capabilities, so that, and I think one of the important things about the structure and the form of ISM and structural modeling is that many of its methods and techniques are focused on overcoming those human barriers. And so those are things that help a group of people, if they're organized correctly with the right techniques, to do what you're talking about, to actually look at the problematic situation in detail without getting lost in it.
Yes. And you see there, Warfield was clairvoyant again, because he said when you conduct an interactive management session, you should do it with 10 to 12, no more, people. And that 10 to 12 people should be a rich cross-section of the stakeholder community who is asking you to help them.
Yeah, it's great. It's a balance, and I think the time that's passed since these techniques were first put together and discussed until now, and the advances in technology, we might now be approaching the time where we may want to think about something different than events, right? Instead of having like a ISM event or an IM event, having actually a component of an organization that's organized to almost continuously view the problems, the current problem state, through the lens of ISM and structural modeling, so that you have a continuous type of operation that has output.
Well, there, a good point. Warfield has counseled us personally some years ago that no, you do not want a standing planning committee. You want a standing or as necessary IM activity, but the participants in each activity must not be the same. Otherwise, you end up believing that you're right instead of questioning what's really needed.
Yeah, that's an excellent point, Jack. I was thinking more along the lines of physical infrastructure as opposed to people. Yes, you'd have to switch if you had an organization. You'd actually have to switch the people out to match the problem you're looking at. But the organizational data set, acquisition, access to, the organizational data, a room, a way to communicate, place to meet, things like that for these people, that would and a common set of methods and techniques that are available, and maybe one or two facilitators.
Yeah.
So they're not the same people, but kind of a component in the organization that's able to do that.
Let's say you've got a group of, let's say, 80 or 100 people that are the representative of the stakeholders. So by this scenario, you would have to do about 10 sessions with 10 to 12 people around around the problem situation, which would then give you 10 separate results. And I'm thinking about a particular case is that I'm working on systems literacy right now, and the way we've done it before has been sort of a mixed method that's got no relation to ISM really, or IM, and I'm wondering about the appropriateness of applying it to that problem situation, and knowing the number of people that would want to be involved in that, it would be approximately 100. So how would you go about, is the 10 to 12 still a realistic figure, or could you do something in a larger group, do you think?
Warfield is quite clear on that, and we really experienced the same thing, is that it's why God invented the trim tab. Okay? If you've got 100 participants in a situation, then between you and that 100, you arrive at an agreement on which 10 to 12 is going to represent the situation.
Okay, that's a good way to reduce. Or
right.
I don't know if reducing the variety is the appropriate term. To represent the variety, probably the more appropriate.
But then a point that isn't typically made is that when the IM station is finished and you have your chart, your graph, then your next phase is to plan an action system. And when you do that, you must review the findings of the initial 10 to 12 with all 100 people and get their reaction to the problem system model, the descriptive model that was created. And if you can't get at least 70% agreement that this is worth trying, then you do not have consensus, and your next opportunity is to waste a lot of time and create political problems.
So if you don't get the 70%, then you would have to reassess those 10 to 12 and run it again.
That's right.
Yeah.
So I think there's another idea here too, and that is if you have the people all together in one physical location, which I think is very important to support group and team learning. You can have the 10 to 12 people that are the active participants, but then those in the same room, you can have backup alternates for each one of those people, one or two, right? So those people are not in the room participating, but they're in the room listening and learning, right? And
Yes.
then something happens to one of the people that's at the table, right? And they have to leave, or they get something happens, then the alternative can set their alternate can set in, right?
Yes.
And so you keep that depth into the organization. And one of the things that happens if you do that is it forces you to organize more or less into interest areas, right? Different facets.
No.
And
How do you know what to organize?
Well, you have a limit, as Peter pointed out. You said 10 to 12, right? And so
Yeah.
you're going to have to somehow pull your group and figure out which 10, right?
No.
And so if you have alternates for those 10, they're going to have to self-organize to do that.
Well, my point is that I doubt that you're qualified to do what you said.
Well,
You don't. This is not a project management job.
Yeah, no.
This is a consensus discovery job.
Sure. So people have to be pulled, right? And if you only have 10 or 12 people that can be active in the event, then you can have more people that are inactive in the event but learning.
Yes.
They're observing, is what I'm saying.
Yes. However, John describes that quite well in the Ford Motor Company project that he conducted for over a couple of years. And one of his students and an engineer at Ford, Scott Staley, became quite enamored with all that. But what they did was that after each session, when they had 10 to 12 people at the table doing their thing, there were at one point some 250 observers, Ford employees, observing the process.
Yeah.
What you must be careful of, however, as noted by Vic Vroom a number of years ago on decision making, you must be careful to not let the 250 people campaign against the jury every night.
Yeah, and
all right.
Yeah, and so when Staley at Ford did their work, they videotaped everything.
Yep.
And that was kind of just distributed information. But today, you could have that in a live broadcast on the internet. So it's simply an idea of getting more eyes and more information and developing larger context of information within the people, in my opinion, anyway. So.
And then the other thing that John mentioned but did not delve into greatly is the socio-technical system. The problem system that's out there that needs to be suppressed has at least 50% of the elements each have belly buttons.
Yeah.
And what you really have to do is discover a way to get the socio-technical system co-evolving, else they never get to the point of addressing the real problem system. This stuck out very clearly in a project in Washington, D.C. that we used this on, because it turns out that government offices, their budget that they're able to get every year is largely tied to the kind of data that they have in their file. Therefore, each one of the government, the 14 offices involved in our study, were very covetous of their view of what the problem was. And they claimed data ownership and would not share their view of the problem system with the other participants. So,
yeah, no, that's very value systems, real value systems, are a barrier.
Yeah.
And it's and if you and normally what I've seen happen is it takes a crisis. And people will go along until they'll stumble along and doing that until they have a crisis that threatens everyone, and then they'll share. But they won't share until they get to that point.
Well, and then when they do share, they do not cohere. They
Yeah.
simply dump their data on each other and
then
walk
there's
away.
the heroes that come out and try to make some sense out of it.
Yeah.
Yeah, no, I've seen that numbers of times on larger projects where they'll try to project manage everything down to the nth degree and kill the information flow, and they'll just get further and further and further behind until they get to the point they say, okay, guys, this whole thing's going to fail if we don't do something different. Who has an idea? And there's always a couple of heroes that stand up and say, I know how to do this, follow me.
Yeah.
Maybe one will make it halfway, the other two will die, and you'll get something. Yeah, well, there you go.
So then, John, two major points. You have to create a model of a descriptive model
Yes.
of the supposed problem system.
Yep.
Then you use interactive management, and particularly ISM, to arrive at a prescriptive model of what to do about that descriptive model.
Mm-hmm. Yes.
And to Peter's activity, you see, if you cannot get a decent prescriptive model for what the belly buttons are supposed to be doing to each other, all the engineers in the world aren't going to help you.
Right.
Can I distinguish three important themes here? What Jack just summarized, the need for the descriptive model of the problematic situation with as few assumptions about what the designed solution will be as possible. That's not a good sentence, but as he said, with the increased complexity in the 80s, there was, because as you frequently discuss, Peter, people have low tolerance for complexity. Warfield recognized that they needed these tools to augment their mental abilities to handle complexity. So the modeling system, the modeling process was developed, and the procedures to handle modeling complex systems. Then this aspect of you need to start with the description before you move to the prescription is something that he really emphasized. You hear it occasionally in various forms, but it's not drummed in as like, it should be one of the one of the 10 commandments, or the 3 commandments of systems engineering should be start with the description before you move to the prescription. I'm sorry, this is not well phrased. I thought I was going to summarize, but
well, I think you captured it quite well.
Okay, good. And then the socio-political aspects of this are a whole separate facet. I just saw a tweet this morning that was people being surveyed, and I can't remember who it was, of what the obstacles are to addressing problems or innovating in an organization, and the political aspects was the number one obstacle,
yeah,
rather than technical or so those 3 facets. Warfield was way ahead of his time, emphasizing those. That people keep rediscovering them in pieces, but the whole systems modeling approach should present them, the three of them together as one story. And as I said, it should be, some set of commandments or that everybody gets drummed into them, instead of saying, oh yeah, that sounds like a good idea to do a descriptive model, but now let's go off and do project management.
Well, yeah, and start coding, because there's so much debugging to be done.
Very good.
So how do you?
Yeah, right. The sooner you start coding, the more time you'll have to do the debugging. Right?
Yeah, yeah.
So how do you, from a systems engineering, how do you wrestle with agile when you're talking about this kind of stuff?
Let me come back a minute, please.
Okay.
So when people are faced with these kinds of confusions, instead of adopting interactive management, particularly if the people are engineers who are anxious to solve a problem, they do not pursue Warfield's advice. Instead, they organize an ISO standards committee. And therefore we have 15288 and all of which are counter effective to creating a decent problem resolution system.
Right.
We need a standard for problem resolution system.
Right.
Yeah.
Right.
So I think there's a couple of issues. I think one is the learning component. So how does a group of people, like you're talking about, Peter, discover what the problem system is that they need to address? You've got 100 people. We need to discover and describe what the problem is before we decide how we're going to solve it.
Yeah.
So that's kind of one part. The other part is along the lines of description of a problem, and even of all of the basic mathematics that Warfield used, like true and false. Those are nominal terms. We're just using nominal measurement scale. We're getting people's opinion. We're getting their knowledge. We're asking people. We ask a person, is this true or false? We're not doing any calculations. Right? Most interesting to me, and we'll go into this more next time, is that Warfield moved Boolean algebra up the scale from nominal to ordinal when he added the greater than or less than to true and false.
Yeah.
And then when we look at the matrix relationships, the matrix structure, he moved it up the scale to interval when he added weights on the relationship.
Yeah.
And so when you now start looking at, how do we go from descriptive or nominal type of work up to prescriptive, which is probably going to be some type of calculation as either interval or ratio, right? How do we walk up that scale? And I haven't seen anyone talk about that specific aspect of how you bring the information and knowledge that organization has using today's type of information technology, and to support a group learning activity so human beings can increase their semantic understanding by creating rich context. And so that's just kind of the problem that we're kind of outlining an architecture for, and we'll be talking about more, as I said, in a couple of weeks.
Mm-hmm. One of the things that maybe we could focus on is the MBSE initiative has now been supplemented by an MBE focus driven by people from, where was it? Not India. Maybe it was. I wish I remember his name. Model-based engineering. Anyway,
Carroll.
Yes, that's right. That's right, Ed Carroll. So if model-based engineering were defined as a group learning activity,
Yes.
then that might get the right ideas in on the ground floor.
Or it might be a group mesmerizing activity.
Right. Well, right. Mesmerizing for their artifacts that, for their, which they want to produce as quickly as possible.
Yeah.
I think there's a couple of aspects here, and I think the idea is that if you have human beings, right, they need to communicate and have developed shared context so that they can understand the semantics. If you have computer-based models, they have to have common syntax and matching between ontologies so that the semantics match. They don't care about, there's no understanding of context there for semantics or machines. And so when we're talking about model-based, right, I think maybe it's good that we have a human model-based. So how do we develop common understanding and human semantic models? And then how do we get computer-based or mechanical systems to interact? And,
Yeah.
So that's the thing that really kind of bugs me about model-based is they don't even make that basic distinction.
Well, the problem is that, well, one of the things I find difficult is the model-based crowd is focused on creating a structural model of the situation, not a transactional model.
Yeah, there's different kinds of models.
We've been doing model-based engineering since Hammurabi, 5,000 years before the current era.
Yeah.
All right, but the reason that we try and model things is some people simply want to perceive a structure, but other people want to understand what happens when you push this button.
Yeah, predictive. And predictive modeling, static structure, behavior, predictive, all of those different kinds of models need different measurement scale.
Yeah.
Right.
Different kinds of approaches.
And so we're lacking, as you were just saying, we're lacking a framework that shows how to go from nominal, ordinal, interval ratio, and how it's possible to do that. Again, I think I've read people I know in Tokyo Institute of Technology. Hiroshi Taguchi was doing really good work on what he called unfolding the boundaries of the model, where you would go through successive scales like that, and you would do tabletop modeling with, between a game and humans and that kind of thing. He said all you can do is have an ongoing unfolding process.
Yeah.
But his work is not really translated into English much, and these people do this work in pockets, but there's no movement, there's no initiative, there's no mandate to bring it all together. Peter, as you would say with Elliot Jack's work, it's beyond the complexity tolerance of most people to see that all of these things need to be brought together rather than focusing on one element of it.
So right now I'm working on some notions that may relieve that, based on our experience with interactive management, and that is for the 12 people who end up on the team, I, as the facilitator, will not accept any person on that team who does not understand that every human is illusionary. And you must have each person must have a second opinion council. We must be in tension. All those 12 people must be in mutual helpful tension in burnishing one another's ideas.
Yeah, that makes sense.
All right. So then the thing I'm working on then says that look, there's 5 levels of systemness in the world. There's a system thinker, which is what everybody spends all their time talking about. But that's only one aspect. The second aspect is system feeling. And everywhere you go, the real brilliant system engineering, system developers always remark on and apply their gut feel.
Yeah, so that's where Tesla did, AC, right? He just, boom, this is it.
Yeah. So then the third level says that you're a system maker. And that is in an education institution is called the laboratory course. That is, you take your system thinking and feeling and work on a typical problem situation to show that your thinking and feeling will converge on something useful. The fourth level of your capability then is a system doing, in which instead of running an experiment in your lab, you participate within other people in a mutual lab. And in that case, by the way, the number N is very important. And well, mental block.
Okay.
Now, oh hell, I can't think of his name right now. But Starkerman, Rudolf Starkerman, and his model of interactive human decision making.
Great.
And then the fifth and final one, once you have demonstrated that you can be a useful co-evolution in a team, is called system being, in which you yourself have created a way of thinking and decision making that is in fact a autonomous self-learning system.
Yeah, almost sounds like TMI.
And I'll tell you, people don't like it when I tell them this, but if you have a PhD, you will never get to the fifth level.
Yeah.
Because you've already demonstrated that you're knowledgeable.
Yeah, it's an ongoing process, but I think those are really good type of common contextual models that we can use to help build your common semantic.
Yeah. Well, now you're on the other topic that says the reason system engineering doesn't work is because they don't understand semantics.
Well, there's a lot of issues there, but I think it's pretty well established that human beings need common context to establish meaning.
Well, yes, but then what are the units of context?
Well, I don't know, but it's just that.
And Korzybski started telling us that in 1850, and Peirce really laid it out 50 years ago. But the reason people become engineers is not because they know what engineering is about. It's because at the age of 16, they figured out that it's furthest down the hall from literature and debate.
Okay.
And so you can never get to systems making, to systems doing, cohering with other human beings, unless you have a common, sufficiently coherent means of expressing your concepts about the world.
I agree 100%. I understand that you need to have that skill, but the point I'm trying to make is that I don't believe, say we have effort, we have resources and effort in the organization, and where are we going to direct that? if we direct that information, those resources and all that effort into developing more computer languages, higher level meta languages, all these things that are executable, those type activities do not help humans create a common context.
That's right.
What can we do to help humans create a common context so they can reinforce, understand, and discover the common semantics?
And I suggest to you that the answer is very simple, straightforward. You conduct an interactive management session on the topic of how can we understand one another.
Okay. Well, yeah, the point I'm trying, and so that's, but most of my experience, I see people go more and more and more toward the idea of strict syntax, strict executable types of modeling approaches, which then do not reinforce or help human beings create a common semantic because they're not helping create the common context. So creating common context among human beings is a different activity.
Yeah.
And I think it gets shortchanged all the time.
Well, but I'm suggesting to you that if we ran interactive management sessions on exactly that issue, that is the problem statement that we might get down the road a hell of a lot further with an ontology than we're seeing all these ontology projects crumble around today.
Okay, well,
actually, I think that pardon me, Joe. I think that the whole systems modeling approach, if we can drum on that one topic, if we say you cannot, you're all taking partial views. You're doing partial thinking rather than talking about systems thinking. Let's talk about partial thinking.
Yeah.
Or biased thinking, as Warfield maybe would say. You're you all have partial views to contribute, but if we really want to address the whole system, we need to have a whole systems modeling approach where we where there's room for every possible perspective. There's no perspective that's wrong. Every perspective has a it could be a contribution. Maybe some are more valuable than others, but they should all be integrable with a whole systems modeling approach, using Warfield's, using Warfield and Peirce and the Krzyzewski and all of the people, Rosen, people who made contributions to the facets of dealing with this, complexity of complexities or multiplexity or we haven't gotten there yet, but whole systems modeling I think might be a phrase that we could continually promote, that would be an antidote to partial systems modeling. We could say, oh, that's very nice what you've accomplished there as a partial systems modeling approach. How does it fit into the whole?
Yep. And there it's important, I think, to recognize Warfield's view on complexity. We misuse that and mislead people all the time. A system is complex or not. A observer of a system is smart or not. Complexity is the nature of the relationship between the system and the observer.
Yeah, that's simple, because if it was, it has to be dynamic, right? So
yeah.
Systems that are complex 50 years ago are no longer viewed as complex today. So yeah, it's changing all the time too.
And the reason then that complexity is increasing is not because our systems are bigger and more complicated. It's because the observers, the people trying to work on them, are simply less coherent as a group as time goes by.
Right. That's why we train teams of specialists to operate our complex system.
Yeah.
You can't go get the janitors off the street and have them operate a very complex system. So yeah, and that's kind of one of the ideas about having a continuous type of capability built in within an organization, not continuous participants, but a continuous capability. What would that look like? What would its components be? And its purpose would be to quickly achieve common context and common semantics among the selected group of individuals so that they're able to have a better description of what the problem is that they're all dealing. Mm-hmm. And with the types of systems we see being deployed every day, they're highly integrated. They have many unexpected features. So I think that would be something that. Yeah. Anyway, we're going to start talking about that a little bit in a couple of weeks.
Good.
Jack, is the word complexness, that's what pertains to the system itself? It's
yes. I in my vocabulary, a thing that qualifies to be called a system has a level of complexness.
Okay.
And that was mathematically defined by Halstead some years ago to be simply the log of the number of things you're going to talk about divided by the log of the number of unique things you're going to talk about. Mm-hmm. Mm-hmm. So you see, a kindergartner as a little human being is not very complex. But when you put them out on the playground, you get a level of complexness that's terrifying. Mm-hmm. Yeah. So, Peter, how does this relate to what you're up to?
Well, what I've been up to is, since observing the enormous variety of different systems, people with PhDs in Berlin purporting to say they found the system's answer.
Yeah.
And primarily in thinking, I thought it might be relatively straightforward, like it was with the ocean and earth scientists, to bring them together to come to some consensus. But I went on this divergence, obviously, as you know, to systems engineers, and have been enmeshed in that for several years, because if we're going to produce something that is useful, it has to include, I think, people that call themselves systems engineers somehow, or at least they've got the word there. And obviously, I've been interested in Warfield since the 80s, when I was introduced to him, actually, personally. And we used some of his ideas at Coors Brewing in the 80s. So I'm very interested in it. I would like to seek a way to perhaps use ISM in bringing some resolution to this ocean literacy, this systems literacy work, if possible. But I'm conscious that it takes time. That was one question I was going to have is, what is this? It's sort of a couple of days activity, isn't it, really?
Well, typically you spend 2, maybe 3 days getting organized and getting clear about what people's ideas are, and building your first problem list, or challenge list, I should say. And then it's very useful to have at least a weekend off, and then come back for another 2 days to arrive at conclusions.
Well, any help that you or Joe might give as I consider this, and we're writing a proposal at the moment to do a workshop to really, I'm wondering how to perhaps, in the course of the workshop, use ISM or IM. So, you would essentially, I suppose we should find 20 people or 24 people, so 10 to 12 with a backup to be in the room, and then to work over the time that you're talking, because they need to be physically present, and we need to have a mix of systems engineers, ocean scientists, earth scientists, atmospheric scientists, climate folks, and social behavioral psychologists, perhaps, and the other point, of course, is representatives of the different systems. What should we call them?
Specialty systems, you mean?
Well, you know, people. Whether you're talking about different systems thinkers or the different systems PhD scholars that are around at the moment.
Well, Kevin, I would just suggest that Kevin has a lot of experience in this, in these types of activities. And one of the things that he did is he took the IM handbook, the interactive handbook, which details these processes, and he pared those down so that they would be more efficient, more effective. And so I would just drop a note to him. After this meeting, I'll actually do that, so that tell him that I think that he might, if he has the time, help you out with that. And
yeah, that's
supposedly Roxana are rewriting the IM handbook.
Well, the first thing you better ask him is what is his proof that his method is more efficacious than John's method. Because when I find people simplifying things, sometimes it means that they're simply taking out the hard stuff. But it's the hard stuff that's the hard stuff. But I'll tell you, Peter, I'm now very convinced, for what it's worth, that you must start with people who agree that you can't name something a system and then proceed to talk about what's inside of it. Yeah, it's exactly backwards.
Yeah.
Until any phenomenon matches a certain set of criteria, it shall not be called a system. It's simply a configuration. And our whole community starts out with just taking the prerogative of calling something a system. Our solar system, our system. Well, hell, what makes it a system or not a system? And you see, Derek Cabrera up at Cornell has been beating this drum now for 3 or 4 years, and we're using it with 5, 6, 7-year-old kids, and they get it right away. You must not call something a system until you state what the purpose is and what the components are. And then what stimulus response behaviors will serve that purpose. And if you can name all that stuff, then you can call it a system. But I keep asking Len Troncalli, he has this notion of a solar system. I said, what's the purpose, Len? What's the stimulus response? And what are you going to do about the 12th planet? You know, and they simply don't have answers. So they simply dismiss the question.
One issue with Peter's situation, and I'm curious, Jack, what you have to say about this, is that Peter is starting from with a design in mind. He because he's had success with the ocean literacy and other earth science literacy pamphlets and frameworks and ways that they fit in with the next generation science standards, he and we would like to see something similar done for systems or general systems or system science.
Yeah.
But that means that we're starting with a design rather than with a problematic situation.
Well,
So
we're starting with a pattern that has worked in different ways for different, as a result of different configurations.
the whole logic of the whole systems approach is that you start with understanding the problematic situation.
Yeah.
So you're not supposed to have your design in your back pocket.
Yeah.
Well, I don't think I have really, and it's. I mean, I have to an extent, obviously, because I've had certain experiences over the last 20 years,
Right.
and so obviously, and I mean, we all have to work with something in our head, otherwise, we probably wouldn't be able to navigate anything.
Yeah.
So, the first problem situation that I observed was what I perceived to be the debate among people with PhDs that their view of systems, i.e. Len or you name it, Midgley, I mean Ackoff, I mean you could Checkland, I mean they all have their take on what systems, Ray Eisen, I mean just any number of authors of books and ideas on systems have their position, and that the need as seen by those who are working with the ocean with its problems, the earth with its challenges, and the climate, in particular, three crucial things that we all have to deal with, could benefit, I observed, from an approach that used the systems approach, for want of a better term, to describe and understand and develop solutions, if you like, and so that's the best expression I have.
Well, Peter, I really admire your work, but I cannot let you get away with saying systems, for lack of a better term. Who in the hell are you to say something is a system?
Well, there you go.
All right. And we got to address that question about each one of us.
So we got 2 minutes left. About
that's next year's challenge, then, Jack.
Yeah.
So we got.
But I think, listening to you and Janet and others, I think you're getting pretty close to formulating a way in which you might arrive at sanity.
Mm-hmm.
I sincerely hope so.
But it will take a educational background far beyond engineering.
Oh, absolutely.
And it must avoid ISO premature immaculation.
Okay, so I would just like to make a couple of administrative comments here. And the next meeting is November 3rd. Mary and I will be presenting our current write-up specification for our software and discussing the architecture that we think is necessary to do some of the things that we'd like to do on our next version. We'll be looking for people to do November 17th, December 1st, and December 15th. Mary and I will do January 2019. So this has been an excellent discussion. Thank you for bringing this up, Jack.
Thank you.
Yep, and I think I think there's a lot of ideas here. I think Kevin would be a really good resource to bring in. Also, the folks in Ireland have done a lot of work with Ben Broom, and they're not engineers; they're psychologists and social thinkers, and that's a new aspect and they call their work collaborative intelligence, collective intelligence. So there's a lot of similar things going on there, Peter. I think that be a lot of help.
Good. Well, this has been fun for me, very useful. I've learned several good things. So thank you all.
Yes, thank you.
All right. Well, we'll look forward to November 3rd and your continued participation.
Very good.
Toodaloo.
Take care. Have fun.